Hello student, this is a continuation to our coordinate geometry, and in the former video we stopped on length of a straight line. So how do we find the length of a straight line? If this is point x to 5 and then this is y 3 4, how do we find the length xy? The length xy is determined by the changes in x1 by Pythagoras, x2 can say x2 minus x1 any squared plus y2 minus y1 squared minus y1 y2 minus y1 squared. In other words, my length xy, this will equal to x1, give me x2, which we can take it as 3 minus 2, then this is squared, plus y2, this is 4 minus 5, this is squared under a square root. Yeah, by Pythagoras he said it will be squared, to be a squared, b squared, then we take the square root to find the length of the longest side, such that I have this is going to be 1, 3 minus 1, 1 squared is 1, 4 minus 5 is negative 1, squared is a positive 1, under a square root, we will get this as root 2. But since this is length, we can say it is units, as my length xy as my length xy. So we can move to the general equation of a line. This is one of the most tantalizing and nice mathematical formulas. The general equation of a line, the general equation of a straight line. Yeah, they are circular lines which are curvature, they are zigzag lines or dented lines, but now this is the general equation of a straight line. The general equation of a straight line takes on the form y is equal to mx plus c, whereby my m is standing for gradient, m stands for gradient of a line, and then c stands for the y-intercept. This guy stands for the y-intercept. So we have our equation here that find the equation of the line passing through the points P, 1, negative 1, and Q, which is 2, 3. So what we do, we can first find the gradient m as part of our solution. We can find the grad or the gradient m, which is y2 minus y1 over x2 minus x1. That is going to be 3 minus 1, the minus in the equation, and then the minus on the y1, then divided by 2 minus 1. This is positive, so this goes to a 4. And now if we leave corona economics, we know that from y is equal to mx plus c, my gradient m is 4, so this is 4x plus c. So I can use the point, if I say using the point P, which is 1, negative 1. So I have here negative 1 will equal to 4 into the x coordinate, which is 1, plus c. These ones I'm just getting coordinates, that this is x and then this is y. Y is negative 1 using this coordinate, x is 1. And then the choice of the coordinate doesn't matter, you can choose any coordinate. So I have my c as equal to negative 1 minus 4, which is negative 5, such that therefore I have my y, or the equation of the line is y is equal to 4x minus 5. That is my general equation of the line. So we can take a look into the parallel and perpendicular lines. The parallel and perpendicular lines. One that you need to know, for parallel lines, when two lines are parallel, maybe parallel horizontally, parallel vertically, or if they are sloping but parallel. If I call this one line 1, this is line 1, line 2, this is line 2, line 1 with the gradient m1, this one with the gradient m2, this has m1, and this one gradient is equal to m2. For parallel lines, their gradient are equal. Remember, this gradient is the flow, it is the slope. Their slope is the same because they are parallel, meaning for parallel lines, the m1, the gradient of the first line, is equal to the gradient of the second line. But for perpendicular lines, for lines that are perpendicular, for lines that are perpendicular or perpendicular any, so for lines that are perpendicular, I have one line meeting the other. This is line 1, and then meeting line 2 at an angle of 90 degrees. If this one is m1 and then this one is m2, we look at the gradient at the product of their gradients as the relation between two perpendicular lines. For two perpendicular lines, the product of their gradients, m1 and m2, this one is moving in a different direction to this one, so the product of their gradient is -1. In other words, the gradient of one line is a negative reciprocal the gradient of the other. As simple as that. So if we can have a question. So we have our simple question that you find the equation of the line passing through that point and is parallel to 3x minus 2y is equal plus 5 is equal to 0. So if we say solution on our solution part, we know that the general equation of the line is in the form y is equal to mx plus c. You're there. So I put this line in this form. So if I take all these, if I take y on the other side, I'm going to have that my 2y is equal to 3x plus 5. I can divide throughout by 2 everything by 2. My y will equal to 3 out of 2, x plus 5 out of 2, such that my gradient, if I call it m1, will equal to 3 out of 2. The gradient, which is the coefficient of x, is 3 out of 2. But this, they want us to find the equation of the line passing through the other point and is parallel. Therefore, my m2, the gradient of the second line, is equal to m1 is equal to 3 out of 2, because the two lines have the same flow, they have the same slope, such that now I can say that from the general equation of the line, y is equal to mx, but for this side it is 3 out of 2 x plus c for this case, such that if I'm going to use the point where the line is passing 1, -2, I'm going to have -2 will equal to 3 out of 2 into 1 plus c, such that my c is equal to -2 minus 3 out of 2. So the LCM is a 2, multiply it here such that this goes to -7 out of 2, meaning therefore my equation of the line is y is equal to a 3 out of 2 x minus 7 out of 2. As simple as that. So we can look at another question. Yeah, so here we have our question that you find the equation of the line, which is the perpendicular bisector passing through the points 5, 4 and 3, 8. So we want the equation of the line, we want actually simply the equation of the perpendicular bisector. In other words, I have a point, I have a line at one end, at the other end I have there 3, 8 as my Q, and on the other end I have their point P, which is 5, 4, and then I have a perpendicular bisector. What do we know about a perpendicular bisector? A perpendicular bisector will divide the line into two equal points, meaning if I call this point Z, which is between the line and the perpendicular bisector, Z is the midpoint. So if I am to get the coordinates of Z, the coordinates of Z are going to be the coordinates of the midpoint of this line. So I have 3 plus 5 divided by 2, then 8 plus 4 divided by 2, so that my coordinates of Z are going to be 8 over 2, which is 4, and then this is 12 over 2, which is 6. So that is now 1 point on the perpendicular bisector. I've gotten 1 point on the perpendicular bisector, meaning now I need to get the gradient of this line. I compare it because they are perpendicular. I compare it with m1 times m2 is equal to -1 to get the gradient of the perpendicular bisector. Then I can get the equation of the perpendicular bisector, such that, so for equation of QP or PQ, equation of the line PQ from y that is equal to mx plus c, my m will equal to change in y, so this can be 4 minus 8 divided by a change in x, which is 5 minus 3, so this is going to be -4 divided by a 2, which is equal to -2, so that my y will equal to, mx -2x plus c, using any coordinate could be 3, 8, my y is 8, my x is 3, so this is -2 times 3 plus c, such that this my c is going to be 8 plus 6, this guy goes to 14, meaning their equation is y is equal to a 2x plus 14, just for beautifying the mathematics. But this one, I can ignore this portion and I go direct and I obtain the gradient of the second line, or the gradient of the perpendicular bisector, such that I can have, if I called this one m1, I know that my m2 multiplied by m1, which is -2, these guys give me -1, such that my m2 will equal to a positive a half. So to get the equation of the perpendicular bisector, to get the equation of the perpendicular bisector, so from y is equal to mx plus c, my m is a half x plus c. So the only thing I'm left is to find the value of c, but now I can come and I use this point. I can use this point, which is the midpoint, such that I can have a 6 on the y component is equal to a half into x, which is a 4, plus c. So this is going to be a 2. Take it the other side. My c is equal to 6 minus 2, which is a 4, such that therefore the equation of the perpendicular bisector takes on the form y will equal to a positive half x plus 4. But I have said that this portion that I've included here, this portion is simply for beautifying the mathematics, so you can ignore it and you go direct, such that you get something very short or an interesting working. Otherwise, like our channel and subscribe to our channel, like our videos, and then in the next video we are doing intersections of lines, intersection between two lines, and then intersection of lines and curves. Okay, so and dare to watch it, such that you become a better mathematician.